So welcome to my walkthrough for the Pearson Edexcel Higher GCSE Maths from June 2024, paper 2, so calculators they're ready. Number 1, nice starter with some Pythagoras. So you'll notice we already know the hypotenuse, so this one is a subtract. So on your calculator, 19 squared, which is 361, and it's a minus 10 squared, which is 100. So on your calculator, you need to be square rooting 261, which calculator might say 3 and a surd and so on, but none of that. All right, it does want it to 3 significant figures, so when that number's rounded off, should be giving you 16.2, although the mark scheme allows 16.1 as well, and for 1 mark, any number between, but if you're told to do something, best do it. 2a, product of prime factors, good old factor trees. Whenever I see a 0 on the end, I always go for 10, because that's always a nice breakdown. So it just asks for a product, so you could just list them, but never does any harm to pop it into index form as well. Perfectly acceptable. Now when you come to and B down here, write them out in full. If you wanted to Venn diagram, you could. I wouldn't bother for 1 mark. So the HCF, you'd multiply all the numbers in common. So there's a pair of 2s, a pair of 3s, so the HCF of these 2 numbers would be 6. And you take the HCF and you multiply it by all the, I always call them leftovers. 6 times 2 times 3 is 36. On we go. So number 3. So you've got H hours, 5,000 bottles, H is 72 over the number of machines. So on a Monday, 72 divided by 6 means 12 is the number of hours. 9 machines is 72 divided by 9, so that would take more machines for fewer hours. Machines took more time, etc., etc. Just a 4. Why is that even on a calculator paper? Who knows? Number 4. Very, very wordy, but always keep your thoughts organised. So there are only red, blue, and yellow. So as soon as I see that, get my thoughts organised, because reading questions twice is a waste of time. There are 24 yellow discs in the bag, and the probability that the disc will be yellow is 0.16. I'm going to do this the non-calc way, because I very much think this could easily be on a non-calculator paper. I'm going to divide by 4 for reasons you'll see in a sec. And the reason is because 0.04 goes into 1 25 times. So I get that there are 150 discs in the bag. Now, as we know, 24 of them are yellow. So 150 take away 24. 126 of them are red and blue in the ratio of 5 to 4. So 2 colours, but 5 to 4 means 9 shares. So 126 divided by 9 means each share is worth 14. Work out the number of red discs in the bag. Red has 5 of those shares. So red accounts for 70 of the discs. Did the non-calc way, but obviously would have been faster on the calculator. Number 5, as you can see, I've cheated. I've actually taken the answer because I'm rubbish with technology. I've taken the answer straight off my work solutions, which you can find linked on the website. I've not filled the table in, so let's talk through that. Always do the positive numbers first, and because it's a quadratic graph, look for lines of symmetry. So let's do the 3 first. 3 squared is 9, take away 3, gives us 6. We are getting symmetry. So this 2 will be repeated down here, and this 0, because there, between 0 and 1, will be the line of symmetry, repeated on the graph down below. So plot your coordinates, and smooth curve, no ruler, smooth curve, as you can see there. It's about the best I can do. Use your graph to find estimates where it's equal to 4. So I've drawn the horizontal line. Whoops. Where it equals to 4. Actually, Y. Start to write X for some reason. As you can see, my solutions come out at negative 1.6 and 2.6. But the mark scheme allows a little bit of leeway. Alright, usually it's plus or minus, so it's minus 1.5 to minus 1.7 and 2.5 to 2.7. On we go. So for number 6, loads of words, loads of calculations. It's only worth 4 marks. You don't have to write them all down. I just do it to show you where the numbers are coming from. So when you've got a wordy question like this, organise your work, ALT, stick your numbers in, 1, 6 and 14. Now that tells us that there are 21 shares. So we can write each of these as being over 21. Now when Tina gives 3/7 of, that doesn't mean take away 3/7, because don't forget the word of in maths means times. Oh, forgot I cancelled them down. Of means times, and 2/3, which is how many sweets Tina has, times 3/7 means she's giving away 2/7 of all the sweets. They go to Andy. Now, if you add on those 2/7 to Andy, oh look, he gets 1/3 of them. We then move on. Next part of the question. We need to know how much of the original sweets Tina had. So we do a takeaway. She had 2/3. She loses 2/7 to Andy. She's left with 8 over 21 of the total sweets. But as you can see, third line down, 12.5%. Hopefully you recognise that. That's an eighth. She gives them. Now an eighth of means an eighth times. So we've got the situation where she gives away 1/21 of her sweets. And guess what happens when we add that on? It means that Andy's got 1/3. It means that Luke has 1/3. Now you can take that further. You can either do over here, you can either go an eighth, 8 over 21, take away 1 over 21 is 7 over 21, which is also 1/3. But I think demonstrating that each of these is 1/3 by a process of elimination, Tina must also have 1/3, because otherwise, where else have the sweets gone? Home we go. So number 7, setting up and solving. So as you can see, it's a quadrilateral. So as soon as we see quadrilateral, we know that the angles add up to 360. So let's add them all up. 4, 8, 13 x's in total. 15, 30, 38, 35. So we've set it up. Let's solve it. We take away 35 from both sides and we divide both sides by 13. Now that's where the easy questions finish. This has got a bit more of a show. So take your 25, use your calc, stick them all in. You could go any way about this. To be a trapezium, you just need to show that it has one pair of parallel sides, and that would happen. That would be the case if either pair, all right, the co-interior angles make 180. All right, so what we've got is on the left-hand side, 4x's is 115. 2x is 50, plus the 15, we get 65. And look what happens if we add them together. Over here, 4x is 100, plus the 8. 3x is 75. Oh, take away the 3, as you can see. So however you want to go about that, however you want to phrase it, it's all good. On we go. So question 8, another one that's a bit strange for a calculator paper, but here we go. So scale drawing, etc., area is 28. So it tells us that the scale is 1 to 5, so there's going to be loads of times in dividing by 5. The real length of QR is 40. So that's in meters. So to change it to centimeters, divide by 5. So we can go with the old, it's a right angle triangle, so we've got the height. So we can say that a half multiplied by the base, whatever that is, times the height, so half times 8 is 4, equals 28 centimeters squared. Or in other words, 28 divided by that 4, we get the length of the base to be 7. So now we can move on. It says work out the real length of PQ, well, we've got it in centimeters. We need to times it by 5 to turn it into meters for 35. No calc needed. Number 9, good old errors and bounds. So the least possible. So when it's rounded off to two significant figures, which in this case makes it nearest 10 pence, the idea of limits, errors and bounds is you can go up and down by half the rounding amount. So nearest 10 pence, go up and down by 5 pence. So £7.30 needs to go down to £7.25. And part B, Layla says that, which is nonsense. And there's lots of different reasons why. One reason could be to explain that 7.3491 is bigger, or even go a stage further, it could be a recurring on the end. So there is no, or you could say there's lots of numbers between those values. I've given a couple of examples, but there you go. Number 10, one of those strange questions, but it's not so much about the trigonometry as it is about the solving. So don't forget, refer to SOHCAHTOA, sine of an angle, there's our angle, there's our opposite, there's our hypotenuse. Sine of an angle is opposite over hypotenuse. On to triangle 2, tan B. Well, in this triangle, there's our opposite, that's our adjacent. The TOA part, TOA, tan of an angle, is opposite over adjacent. So let's multiply both sides by 8. There'll be a smart aleck about it, obviously with the 4 and so on, but I don't bother with that. Let's multiply both sides by 4. Let's take away 8 from both sides while adding 8x to both sides. So x is going to be 20 cancels down. Obviously, we can divide that by 4 as with that. So x is 5/4. If you want to do decimals, 1.25, also correct. Number 11, because I'm useless with technology. Yep, I've already cheated. So don't forget, cumulative means add up as you go along. So 7, add on the 21, add on the 15, and so on. On the next page, yes, I've already drawn the graph, but don't forget when you're drawing cumulative frequency, you must use the upper class boundaries. So it's those values on the x-axis plotted against those values on the y-axis. So there you go. Join them up with a ruler for me. Ruler's easier than freehand. It does actually specify cumulative frequency graph. So they're not saying polygon, they're not saying curve. So it's a free choice. And if it's a free choice, I'll go for ruler all day long. So interquartile range, that's my red lines drawn on here. So quarter of 60 is 15. 3/4 of 60 is 45. So go along to your graph. I've missed a little bit, but don't forget, it's an estimate. All right, I get the readings of 6.4, 2.7, and so I'm getting, when you subtract those, I'm getting the reading of 3.7. As you can see, mark scheme allows a quite wide range, 3.4 to 4, so quite an easy answer. Use your graph to estimate parcels of weight greater than 7.4. So that's the green line. There's my 7.4. I go up, I go along. It's kind of just 50-51. All right, give or take. So my answer is 9 or 10. I've gone with 10. Mark scheme allows anything from 7 to 10. So obviously I'm at the upper end. Trying hopefully yours will be a bit more accurate. You'll be around the 8 or 9 mark. On we go. So inverse proportion, don't muck around with the fish sign, any of that nonsense. Inverse proportion, just go straight to it's going to be a number over, because it's inverse. And so our formula, the equation it wants, is going to look like that. That's your hint. In other words, we need to find k. So let's stick in what we know. 3.5 equals k over d squared. So to find k on my calc, 64 times 3.5, I'm getting 224. Part B, so we're going to recycle that, we're going to reuse it. We need to find d when f is 10, so let's replace f with 10. Multiply both sides by d squared. So we need to do d squared is 22.4. So we're needing to do the square root of 22.4. Only the positive answer required. I'm getting 4.7328 and so on. But don't forget to do as you're told. 3 sig figs is 4.73. Done. So as you can see for question 13, cheated a little bit, but just so I can do a bit more explaining about what's going on. So first of all, when you're asked to sketch the inequalities, don't assume you're going to, it's only 3 marks, don't assume you're going to fly through it in 2 minutes. These are one of those questions where it's worth taking the time over because they're easy when you know how. So as you can see, I've drawn the x equals 2 line. Just give it in. Don't muck around. X equals 2 vertical line in red. Then I've drawn the line y equals -3 horizontal line in blue. Other two, do a quick table of values. So as you can see, y equals 2x plus 1. Could have done it the y equals mx plus c version, as you could with the orange really, but a little bit more complicated. So, but you could go table of values, pick a couple of nice values of x, substitute them in. As you can see, I've plotted the coordinates there, and again, you get your green line. For the orange, you'll notice 3 and 2 go into 6, so zeros were the best numbers to pick. So I picked 0 for x, 0 for y, and then just solve it in your head. But if you want to do a bit more working out, as you can see, they always give you a little bit more room for these sort of questions. Now, the big deal for a lot of students I've worked with is which side of the line, because the obvious R is the one in the middle, but I've seen it be that one, and so on. I've seen it be in the bottom right-hand corner. Don't just guess. One thing at a time. Here's how I go about it. So on the red line, x is less than or equal to 2. So that's less than is an easy one. That's to the left of that line. Or in other words, could put the arrow in here. Doesn't matter how you doodle it. Y is greater than or equal to -3. So again, needs to be above that line. So you're already narrowing it down. But these diagonal lines, well, not diagonals, you know what I mean, these sloping lines, not as easy. So I always do a test coordinate. So let's do a test for the green. Am I wanting this region over here? Am I wanting this region down here? I'll pick the test coordinate as, just pick something obvious. Always pick zeros if you can. Always pick positive numbers. I'm going to pick the coordinate 6, 0. Now, when I sub 6 and 0 into this equation, does it work? So let's replace the y with 0. Let's replace the x with 6. And we get 13. 2 6's plus 1. Is 0 less than or equal to 13? Yes. So this region, that side, is what we're interested in because the test point worked. We don't want the left-hand side, kind of the upper left of the green. Not what we want. Let's move on to the orange. Same goes. I'm going to use the same coordinate. Let's replace x with 6, y with 0, and see if it still works. So we've got 3 x's, that's 3 6's, that's 18, added to 2 y's, which is nothing, is 18 less than or equal to 0? No. So we're not looking for this side of the orange line, we're looking for that side of the orange line. So now you can start picking it. So we need to be above the blue. We need to be to the left of the red. So it's in this quadrant sort of thing here. We need to be under the green in that respect. In this direction of the orange. So although I did say at the start, don't assume it's that region. In this case it is, but you just can't assume it. Now that's took me 4 or 5 minutes to explain, but well worth it, because obviously if you shut up and get on with it, you'll be doing those questions in 2 or 3 minutes with good revision and practice. So as you can see, I've also cheated for question 14. So for part A, only pay attention to what I've done in the red. Let's explain what the heck's going on. So calculate an estimate for the acceleration. Obviously, its velocity is decreasing, so it is deceleration, hence the minus, or feel free to put it in words. But let's worry about the triangle. Now, when I've drawn this triangle, not only does it have to be a tangent at 5, try not to cross the line at all, but you'll notice I've tried to make it end at 10. Reason being, giving me a height of 10 gives me nice numbers to work with, a bit less of the guesswork, sort of can reduce the chance of getting an error outside of what the mark scheme's allowing. Looking at how long I've made it in terms of over here, I get it to go from 3 to 7.8, which is a horizontal difference of 4.8. So when you've got a velocity time graph, how do we find the deceleration? We do the vertical change. That's the actual deceleration, the actual change in velocity, divided by the time it takes. In other words, distance divided by speed equals time. But it's also finding the gradient of the line. Sometimes they ask you to determine what does the gradient represent. In a velocity time graph, it is the acceleration, or in this case, deceleration. As you can see, the mark scheme allows anything from -2 to -2.8. Mine's at the lower end of that, but it's all good. Now for part B, I'll just peek at it just to show you. It just basically says work out estimate for the distance. So distance on a velocity time graph is the area under the graph. So what we're needing, if I change it to green for a sec, what we're needing is the area of these three trapezia. Now I do all my working out on the graph. As you can see, I've drawn the vertical lines in because what you're really interested with area of trapezia is heights. So I'd estimate the height here to be 25, estimate of the height there to be 16, height there to be what we got, 4 to, looks like 9 to me, and that looks like 4. Now the formula for the area of a trapezium is add together the parallel sides, in this case 41, but then you halve it and you multiply by the vertical distance between them, known as the height of the trapezium. But in all cases, we're halving and timesing by 2. Well, they just cancel out. So in other words, quick way here was just to add them together in pairs. 9 plus 4, 13. So the area of each is 41, 25 and 13, give or take, giving you a total area covered of 79. Mark scheme allows 78 or 79. So again, these are, when you practice these, they become a lot faster. You know, what's that? 6 marks. So the time lost, spending a bit more time on the previous question, 13, is made up for on a 6-mark question here. With practice, you can get this down to 3 or 4 minutes without all my waffle. On to question 15, strange looking rationalizing question, but it is what it is. So we need to multiply top and bottom by the conjugate, or in other words, change the sign. Now this one's a lot easier than it actually looks. So as you know, top times top will just result in root of a, take away 1, because you just times in by 1. Now on the bottom, it does want simplest form. So when you do bottom times bottom, as you'll know from rationalizing these type of denominators before, you only need 2 loops. Root a times root a, which is root a squared, or in other words, a, and you get negative, because that's your other loop, -1 squared, or in other words, -1. And the middle terms, if you did root a times -1, 1 times root a, they just cancel out. So don't worry about those. On we go. So solving, whenever you're solving, well, it's already factorized. Now it's a quadratic inequality. First thing I look at is it a positive x squared? Yes, it is. So when you draw yourself a little diagram, it's wanting below 0. So that's this portion of the graph. So whatever the solutions are, we're looking to be between them. So it's going to be one of those continuous answers, not a broken answer. So now we can look at solving, which we just do, pretend it's an equals sign. Change the sign, so x plus 5. So one of our solutions, or critical values, if you've been taught that way, will be -5 here. change the sign, divide by the coefficient of x. So positive 3/4 will be the larger of the two solutions. That goes on the right. -5 goes on the left. On we go. So here we go for number 17. Now this is more about explaining what's going on because it's actually quite a simple question if you know about our old friend when you've got a linear scale factor. It's just a length, so you just multiply it by a number, but when it's an area, it's length times length. So you get a squared of the scale factor. And applying that to volume, length times a length, you've got cubes. So if you want to work backwards, you're going to have to cube root and square root to get your linear scale factor. And in this case, linear means height. So let's take our information. You're told mass. Now, mass is a three-dimensional thing, and it's no coincidence these are two cube numbers. So based on them being related to volume, we need to cube root them to get a proportion of their height. So it's not the actual height, it's just a proportion. So in a linear sense, there's a scale factor of 1.25 or 1.25. We're told the scale in terms of the surface area, we've got two square numbers, so square root them to get their scales. Their scale factor is 3. But in terms of linear, it's 4 to 12. So we've gone from surface area square rooted, and now the numbers come quite easy. It's one of those connected ratios question. We've got 5 and 12 in the middle. Their common ground is 60. So let's scale both the ratios up. Multiplier of 12, so the 4 becomes 48. Here, multiplier of 5, so the 4 becomes 20. And obviously, that's a perfectly acceptable answer. Doesn't tell us to give it in its simplest form, but if you want to. Everything divides by 4, gets no simpler than that. Number 18. Now you could start the process of doing a probability tree. I wouldn't, because there's 3 possibilities. You can't take more than one green counter. There's just so many things. It's one of those listing. So make a list. Now, the only way we can get more yellows than red at the end of this experiment that Tony's doing is if he picks 3 reds in a row. Now, if you were doing a probability tree, you'd have the numerators as 4, 3, 2, denominators as 8, 7, 6, and it gives you 2 over 28, aka 1/14. But there's another possibility. You can't pick a yellow. That would knock you down to 2 yellows, and you can never have fewer reds than 2 if that's the case. So if you pick out a yellow, there's only 2 more picks. Reds can never get, so picking a yellow is not part of the solution. The other solutions, it's red, red, green. Now that can be in any order. Now when you do red, red, green, you don't have to write all the working out. All right, I know it's worth 5 marks, but you don't have to write all the working out. Red, red, green would be 4/8, 3/7, 1/6. But there's also that green could come out second. That green could come out first. And these will all have the same numerators, just juggled about, and the same denominators, just jiggled about. So they'll all have the same answer. Obviously, you could have just trebled the top one. But they are the only 4 things that can happen, the 4 situations, the 4 branches. If you were going to draw a probability tree, you'd still be doing it. But the only branches you're interested in are those 4. So we add them up. And there's our answer, 5/28. Next, on to a not so friendly vectors question. Now, as soon as I read midpoint, I stick on halves because they're worth a half each. As soon as I see that OA is A, I label it. OB is B, I label it. We're told that BN and BNC are 4 to 5. So again, fractions, 5/9 and 4/9. And at the top, we've got the KB. We'll worry about that later. So let's discuss the journey M to N. If I want to walk from M to N, I'd go to O first, and from O, I'd go to B, and from B, I'd go to N. Now, the first 2 parts of that journey are straightforward. M to O is negative a half A. We're going against A, and it's a half of the whole line. O to B is the easy bit. That's just B. But B to N is the tricky bit. It's 4/9 of B to C, and we haven't really looked at B to C. So on the next line, let's give ourselves a bit more room. Let's look at B to C in a bit more detail. Let's do the journey. To go from B to C, we go against B, we go with A, and we go with an amount of B. There we go. Unfortunately, it wants simplest form. This is where calculator can help with an algebraic vectors question. Let's simplify the A's. So we've got negative a half, but we've got added to 4/9 of A. Multiply them, we get negative an 18th. Doesn't look very simple, but I assure you it's correct. Then we've got the positive B, but then if we expand these brackets, positive 1B, take away 4/9 B, we've got positive 5/9. And then we've got the final bit to jump through. We've got 4/9 of KB. As weird as the answer looks, it is correct. It's as simple as it gets. Part B, you can just see it at the bottom. Is MN parallel to OB? Now, there's lots of ways you can go about it. There's the line MN. Now, it looks parallel, but you can't go about it that way. Is it parallel? The answer is no. All right, lots of different ways you can go about it. As you can see, O to B is all in terms of B. Well, this has a bit of A in it. It's got lots of B in it, but this has some A in it, so it just can't be parallel. The other argument is there is no common scale factor. You can't multiply B by a number to get this because there's an A involved. So lots of ways of going about it. Don't overcomplicate, only worth the 1 mark. On to number 20. So keywords, turning point, that's got to read into your brain, complete the square. Not nice when there is a 2 next to it. Whoops. Not nice when there is a 2 next to it. So let's take the 2 out. We halve the coefficients of the x squared and the x. We leave the 7 well alone. We complete the square on the square brackets. So we halve it, and then we square it and take it away, leaving the +7 out of the picture. We double everything in the brackets, so double this shebang. Now that actually tells us that the minimum point, treat it like a solution, you change the sign. Then we've got two lots of -9 added to 7, or in other words, -11. And that is your minimum point, 3 minus 11. On we go. So number 21, you can do the transformations in any order. Now, how would I go about it? As you can see, you've got x being replaced with -x. Now, if you don't know that, well worth learning that that's a reflection in the y-axis. That would take this coordinate to here. This coordinate, 3 along. Alright, so total of 4 away, so 3 from the x-axis, 1, 2, 3 to there. And the minimum point's quite important, and that would reflect over here. You don't have to draw it, but that's where it's looking. Plus 2 shifts a graph up 2, so each x finishes its journey at the top. Whoops. On the axis. Join them up with a curve that's almost certainly better than mine. But you know what? I'll take that. But you could do you could have moved it up first and reflected it. There's no order importance in these. And finally, for number 22, I'll get the ruler on. I'm not going to write all the waffle out. That's your job. Let's do each bit in turn. Let's get a line on. So that line there, that line there is the radius. That line there is the radius. So the first thing to point out is that the radii are equal. The second thing to point out, radius meets tangent at a right angle. So they definitely have an angle which is the same. And finally, we have this line here from P to O, which they share. So in actual fact, they have a right angle, they have a hypotenuse in common. That's the line from O to P. They share that line there. And we have another side. They've got the right angle, they've got the side, which is the radius, and they've got the hypotenuse, which is common. Get those keywords into any sentence you want, and you are getting all the marks. They're giving you plenty of room, as you can see. But I would say 3 good sentences will see you right on that. So hope all that's helped. See you on the next one.